Okay, so a couple of videos ago I told you that we're going to be using Pascal's triangle to help us with what's called the binomial theorem. Now the binomial theorem, like Pascal's triangle, shows up all over mathematics. We're just going to barely scratch the surface of it. So here is the binomial theorem. It looks like a mess. You don't need to worry about that. I just showed it to you. That way if you see it, you're like, hey, that's binomial theorem, and we're going to move on. Pretty much what we're going to be doing is translating the binomial theorem back into Pascal's triangle, because the binomial theorem is created from Pascal's triangle in the first place, so why not use it? So the connection between binomial theorem and Pascal's triangle, pretty much binomial means we have two pieces, a plus b to the n power. Here, n is the row number of Pascal's triangle. Again, we always start with the zero row. We start the zero row at the very top and work our way all the way down to whatever row we need to be in. We call that n. The powers of a decrease as we go from left to right in Pascal's triangle. The powers of b increase as we go from left to right in Pascal's triangle. And the sum of the powers, a and b, will always add up to n. And finally, the numbers in Pascal's triangle are the coefficients for each term in the expansion of the binomial theorem. So let's go ahead and just do some examples. So we want to use the binomial theorem and Pascal's triangle to expand this binomial. Here I have the binomial a plus b quantity to the zero power. The power tells me I need to be in the zero row of Pascal's triangle. So the zero row is just simply 1. Okay? So what that means is anything to the zero power is 1. So I expanded it. My answer is 1. Done. Too easy. Next problem. Use binomial theorem and Pascal's triangle to expand each binomial. I have a plus b to the first power. So I'm in the first row of Pascal's triangle. So remember, Pascal's triangle starts with row 0, so row 1 looks like this. So this is the row I'm focused on. So what that means is I'm going to have 1a to the first plus. So what I should say before I start doing that is, again, like we said when we first were talking about the binomial theorem, is the powers of a decrease from left to right, and the powers of b will increase from left to right. So, and the numbers in the row that we're working on are the coefficients of a and b. So what this means is I have 1a to the first, b to the 0, plus 1a to the 0, b to the first. Again, powers of a decrease from left to right, powers of b increase from left to right, and the numbers in Pascal's triangle are coefficients. Now I can clean this up as much as I want to. Anything to the 0 power is 1. So I have 1a to the first times 1 plus 1b to the first times 1. Well, 1 times 1 is just 1. So 1a to the first plus 1b to the first. And again, clean this up. So I have a to the first plus b to the first. I've cleaned it up as much as I can. So this is my final answer. Okay, not too bad. Let's move on to another example. Here I have a plus b quantity squared. Now, you could probably do this. You should know that this is just simply a plus b times a plus b. You can use square root of box there. No big deal. But we're going to practice using Pascal's triangle. The square tells us we're in the second row of Pascal's triangle. So here's the 0 row, here's the first row, here's the second row. Okay, so this is the row we're working on. Again, powers of A decrease from left to right, powers of B increase from left to right, and the numbers in the row that we're working on are the coefficients. So I'm going to have 1, 2, 1. All of these pieces are going to have an AD. What I need to do now is take care of my powers. My highest power is 2. So 2 for the A, 0 for the B. 1 for the A, 1 for the B. 0 for the A, 2 for the B. Again, powers of A are decreasing, powers of B are increasing. These are all positive, So plus in the middle. Now I'm going to clean it up as much as I can. So I have 1a squared plus 2a to the first b to the first plus 1b squared. Cleaning it up even more, I have a squared plus 2ab plus b squared. And that's it. And this is the exact same thing you would have got if you did 4 in a box up here at the top. That was a pretty easy example. So what we're going to do now is crank things up just a little bit. Same idea. I want to find a plus b quantity to the 6th power. Now, you could do a plus b times 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 a plus b. Do that 6 times. All that FOIL is going to take a long, long time. Instead, we're going to use Pascal's triangle in the binomial theorem. The 6th power on the outside means we're in the 6th row of Pascal's triangle. So let's draw up the triangle first. We have 0 row, 1st row, 2nd row, 3rd row, 4th row, 5th row, 6th row. Okay, so this is the row we care about. Again, these numbers are the coefficients of A and B, so that's where I'm going to start. I'll give myself some room. I gave myself too much room. So I'm going to just spread this out so I have plenty of room to work. Okay, and each of these are going to have an AB because that's what I had inside my parentheses. So AB, 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 AB. Okay, now these are all positive, so I'm just going to go ahead and put my pluses. And now, again, powers of A decrease as we go to the left, or sorry, go to the right. Powers of B increase as we go to the right. So our highest power was 6. So 6, 0, 5, 1, 4, 2, 3, 3, 2, 4, 1, 5, 0, 6. A good way to double check yourself to make sure you have the powers right is these two powers will always add up to what your power on the outside of your parentheses was. Power on the outside of the parentheses was 6. Each of these powers will add up to 6. 6 plus 0 is 6. 5 plus 1 is 6. 4 plus 2 is 6. 3 plus 3 is 6. Okay? So now I want to clean up as much as I can. So I'm going to do that in green. I have a to the 6 plus 6a to the 5th b plus 15a to the 4th b squared plus 20a cubed b cubed plus 15a squared b to the 4th plus 6ab to the 5th plus b to the 6th. So if I did all that FOIL at the very beginning, this in green would be my final answer. Okay, so you can see how Pascal's triangle, aka the binomial theorem, really makes expanding binomials to any power super, super easy. As long as you know how Pascal's triangle is connected to the binomial theorem, this is easy. It will take a little bit of practice, and we're going to do more together in class, so just watch out for that. But that's it for this video.